today we're talking about relations and functions. A relation is any time you put x's and y's together. So a list of ordered pairs is a relation. A grouping of points on a graph is a relation. A line is a relation. Functions are specific types of relations that meet a certain set of standards. The biggest rule with functions, honestly, there's a whole list of things that it takes to be a function. More important is what makes it not a function. A function cannot have any repeated x values. So you might want to add this little note, no repeated x values. The domain is the input, like the x values. The range is the output, the y values. And here's the characteristics of functions. This thing at the bottom is called a mapping diagram. The biggest thing is that is number 4. An element in A can't be matched with 2 elements in B. This mapping diagram says that one of these points is 1 o'clock, 72 degrees. Another point is 2 o'clock, 74 degrees. So do you see how the ones on the left are linked with arrows to the numbers on the right, and that creates ordered pairs? If something on the left is linked with 2 separate things on the right, that means that that x value is used twice, and that would make it not a function. So no repeated x values. In example 1, we need to decide, is each relation a function or not a function? So in A, they're saying the input is A, B, C, the output is 2, 3, 4, and here's the actual ordered pairs, A2, B3, C4. Look specifically at the x values. Are there any repeated x values? No. So this one is a function. A is a function. B, it shows you the inputs, it shows you the outputs, and it shows you the ordered pairs. Really, all you need to look at is the ordered pairs, and look carefully at the x values. Are there any repeated x values?
Yeah.
Yes. Repeated x values means that this is not a function. And C is a mapping diagram. This tells us that one of the points is A1, another point is B1, another point is C1. There's no repeated x values, so this is a function. I'm going to add D over here and show you a mapping diagram that's not a function. So here's our x's, here's our y's. This one is not a function. The value 1 is linked to 2, so that's the ordered pair 1, 2. It's also linked to 3, that's the ordered pair 1, 3. So x is used twice, that makes it not a function. Y values can be used more than once, that's totally fine. X values cannot be used more than once. The vertical line test helps us to determine whether or not something is a function. It's a visual check to see if it's a function. If you have some sort of a relation and you put vertical lines through that, each vertical line can only touch the relation at one place. So on A, if we put a vertical line here, it only touches that one point. A vertical line here only touches 1 point, 1 point, 1 point. This one's good. This is a function. What if there was also a point right here, the one I'm adding in orange? If I added that point in orange, would A still be a function? No, because a vertical line would touch more than 1 point. How about B? Is B a function?
No.
Not a function. Because any vertical line would definitely, well, it would help if I actually drew a true vertical line. Touches two places, so it's not a function. What about C? Function. Okay, function, not a function. Easy peasy?
Yes.
Function notation. What you really need to know with function notation is that y equals and f of x equals are the same thing. F of x is a label that means the same thing as y equals. And I'll show you on the next slide why mathematicians love function notation so much. It tells you a lot of information. It tells you the name of the function. F is the name of the function. It tells you the domain, the input value, and it tells you the output, the answer, the range value. It is read f of x. So put a box around where it says f of x. That is incredibly important. F parentheses x is read f of x. On the next slide, we will evaluate. You can use any letter to name a function. So f of x, g of x, h of x, j of x, p of x, whatever letter you want. This one is g of x, and the function is 3x minus x squared. G of 2 is telling us, take the g function, and we're going to plug 2 into it. I would strongly suggest that you put parentheses around these if you're putting it into a calculator, but you don't have to. 3 times 2 minus 2 squared. You can plug this into a calculator or do this kind of in your head. What is 6 minus 4? 2. Write your answer with that original label. G of 2 equals 2. If we had the equation y equals 3x minus x squared, see how that's the same as what we're working with? If you write y equals 2, if I don't know what function you plugged what number into, I would have no idea where that y equals 2 came from. With g of 2, I know that we took the g function, we plugged 2 into it, and we got 2 as our answer. It gives you a lot of information about what was done and what your answer is. This also tells us that the point 2, 2 is on this graph. So it gives you a lot of information. That's why mathematicians love it. On B, g of negative 4. 3 times negative 4 minus negative 4 squared. Anytime you're squaring a negative number, put it in parentheses, please. On your assignment, please make sure you write the label. So with your answer, put g of whatever it is you plugged in. Okay, g of 2/3 is honestly kind of cruel. 3 times 2/3 minus 2/3 squared. I would definitely do this on a calculator. You get 1.56 or 14/9. I would accept either of those as an answer if I gave you one like that on your assignment. Okay, the last thing we need to talk about is domain and range of the function. If you're given a list of ordered pairs, domain and range are super easy. If you're given something like area of a square, it's a little bit more complex. So if you're given a list of ordered pairs, for the domain, you are simply listing the x values. So I will highlight the x values in yellow. You want to write it in numerical order from smallest to largest and no repetition. So our smallest x value is -3. Looks like they're perfectly in order, aren't they? -3, -1, 0, 2, 4. Your range is your y values written in numerical order from smallest to largest. Anyone notice anything about our y values? There's 2 4s. You don't have to repeat the 4. You don't have to write the 4 twice. Your range involves the y values -1, 0, 2, and 4. So you don't need to repeat anything. Just write the y values in numerical order from smallest to largest. Okay, area of a square. And for our sakes, I'm going to call this y equals x squared, because we're going to write the domain and range in terms of x and y, because that's what we're used to. So the domain, if our equation is area equals the side length of a square squared, can a square have a side length of 5?
Yeah.
Yes. Can a square have a side length of 0?
No.
No, that'd make it a point. Can a square have a side length of -5? So what x values can we use, or in this case s values? Our x values need to be larger than 0. Then think about range. If we put in numbers that are bigger than 0 and square them, what types of numbers are we going to get from this equation? Numbers that are also bigger than 0. A lot of times the range is all real numbers. Sometimes the domain is all real numbers. If I gave you the equation y equals 2x squared plus 3x, your domain would be all real numbers, and your range would be all real numbers. You can plug anything into that equation, and you will get any kind of number out of that equation. But notice up here it says, if weekly pay is a function of hours worked for a 40-hour work week, the implied domain is 0 less than or equal to x less than or equal to 40, because theoretically you're not working more than 40 hours per week, but you're not working less than 0 hours. So your domain has to be somewhere between 0 and 40. And then your range would be something between 0 or bigger than 0. All right, your assignment for 4.3 starts on page 185. Sorry about all the noise, those of you watching the video. I think they forgot I'm recording, but that's okay. Nobody said anything too terrible yet.